Good morning, dear students. I am Harminder Singh, Senior Lecturer, Government Polytechnic College, Amritsar. Today, we shall discuss about the automotive braking system. This is based on the friction, which is a necessary evil. So, hence we can make use of the friction to stop and slow down the vehicle. So, automatic braking system is of two types. The service brakes operated by foot pedal, which slows or stop the vehicle, and second is the parking brakes operated by foot pedal or hand lever, which holds the vehicle stationary. So, now these two types of brakes are there. The service brakes, which we use usually to stop and slow the vehicles, and the other is parking brakes. Most automotive service brakes are hydraulic brakes. They operate hydraulically by pressure applied through a liquid. The service or foundation brakes on many medium and heavy duty trucks and buses are operated by air pressure. So, these are called air brakes. Now, the hydraulic brake is used on light vehicles, and for heavy vehicles it is medium. For heavy vehicles it is air brakes, because liquid is viscous. So, it takes times to travel, whereas the air under compressed air behaves like a liquid, incompressible. So, the brake is very apt. Then friction and braking. As you know, the friction plays very vital and important role in braking. If there is no friction, no braking. So, friction is the resistance to motion between the two objects in contact. It varies with the force applied between the sliding surfaces. And now, the two sliding surfaces mean the brake shoes are stationary, where the brake drum or the disc is moving. So, the friction between these two is responsible for the braking, and the roughness of the surfaces and the material of which the surfaces are made. Right. So, the friction depends upon number of 1, it is the friction, and that depends upon the roughness and the material. The amount of friction also depends on whether a liquid such as oil is between the surfaces to provide lubrication. Sometimes the brakes is leaky, or you can say the hydraulic oil is leaked out through the wheel cylinder, and the brake shoes gets wet. So, this liquid acts as a lubricant, which decreases friction and hence braking. Friction in vehicle brakes. When the brakes are applied, a fluid flows through tubes, that is pipe connecting master cylinder to the wheel cylinder. Those pipes are called tubes. So, when the brakes are applied, a fluid flows through tubes to the brake mechanisms at the wheels. The brake mechanism apply force on a rotating part, so the wheels are slowed or stopped. There are two types of wheel brakes mechanism, that is drum and disc. In drum brake, the fluid pressure pushes lined brake shoes against a rotating drum, and in disc brakes the fluid pushes lined brake pads against a rotating disc. Now, the friction between the stationary shoes or pads and the rotating drum or disc produces the braking action. Now, you can see here the friction is responsible for braking. So, it is the friction between the brake shoes and pads responsible for braking. Then friction between tires and road slows and stop the vehicle. Since the static friction is greater than kinetic friction, the vehicle stops in shorter distance. If the vehicles do not lock, if the wheels do not lock, however, the brakes must be applied to the point at which the wheels are almost ready to lock. This is the principle of anti-lock braking system. Now, let me clear this point. As we all know about the friction, that is static friction and the dynamic friction. Static friction is always more than the dynamic frictions. Now, if the wheel gets locked, then the dynamic friction will come into play. We want to stop the vehicles as early as possible in shorter distance. So, hence the principle of static friction has to be applied by using some advanced mechanisms which are called anti-lock braking system, or the brake pedal is pressed up to a point at which the wheels are almost ready to lock. Then only the static friction can be maintained, otherwise it comes into the dynamic friction and the vehicle will travel larger distance than the static friction. Now, why we use this static friction? Because it prevents wheel lockup, ABS brake, it prevents wheel lockup and tire skidding during hard braking. What is hydraulics? We use the hydraulics brakes in automobile engineering. So, let us see what is hydraulics. Hydraulics is the use of liquid under pressure to transfer force or motion or to increase an applied force. So, hydraulics, it is the liquid which is the medium that multiplies our applied force. If a driver depresses a pedal with 10 Newton force, and with the use of this hydraulics, it can be multiplied by 3 times or 4 times or many times. The pressure on a liquid is called hydraulic pressure. It is the hydraulic pressure that forces the brake shoes into contact with rotating drum to produce braking. The liquid travels from the master cylinder to the wheel cylinder through the tubes that forces the brake shoes to make contact with the rotating drum or disc. Why only liquids are used? Because of its property. The property is incompressibility of liquids. The liquid is incompressible, whereas the air is compressible. That is why we bleed the brakes. The removing of air from the brake system is called bleeding. Liquids are used because these are incompressible, though the liquids, practically the liquids are compressible, but to some extent, very small extent. So, that is why it is neglected and the liquids are considered as incompressible liquids. So, hence in this figure you can see how it affects the braking. Now, take this first case, the weight is put on the cylinder which is filled with air. The air is filled in this cylinder. When a weight of 100 pound or 45 kg has been put on this, it will compress this air will be compressed to the smaller volume. Hence, the volume is reduced. and the load will travel from this place to this place. See the liquid case, here it is a liquid, this jar is filled with the liquid up to this level, then the same weight is applied over here and the weight does not move downward. So, that means the volume of the liquid in the first cylinder or in first position remains same as in the second position. So, see in the comparison from first case to the second case, air is compressible. Earlier the volume was so much, now the volume has been reduced to the minimum possible. You can say the air is compressed and the volume is reduced, and in this case liquid is incompressible and no volume is reduced. So, that is why we use the liquid instead of air. Though we are using air brakes, but that air is not in this form, that air is in the compressed form, and the compressed air behaves like a liquid. It flows instantly and offers no resistance to flow, which is viscosity. Now, we are discussing about the incompressibility of liquids. Increasing the pressure on a gas, as you have seen just now, the increasing the pressure on a gas will compress it into a smaller volume. However, increasing the pressure on a liquid will not compress it. The liquid is incompressible. That makes possible to transmit force or motion. I think it is quite clear from the figure previously shown. See it again, the air is compressible, liquids are incompressible. That is why we are using liquids. Transferring force by a liquid. How we are transferring force through a liquid? The force that is applied to a liquid is transmitted by the liquid in all directions to every part of the liquid. The size of the piston determines pressure. The smaller the piston, the greater the force in the master cylinder. See here, in this figure, it is clear that we are transferring force. The liquid is filled in this master cylinder, we press this pedal and the piston moves, and the liquid in front of the piston is pushed with a force that is forced through the tubes, and finally it reaches to the wheel cylinder that is responsible for braking. Okay. And as I have told you that the smaller the piston, the greater the force in the master cylinder, and bigger the output piston or wheel cylinder, the greater the output force. It means the master cylinder area should be smaller than the area of the wheel cylinder. If the area of the master cylinder will be smaller, it will if the master cylinder's area is smaller than the wheel cylinder, the greater force would be at the wheels. If the area is doubled in the wheel cylinder, that means we are multiplying force twice. If it is thrice, we are multiplying the force 3 times. So, that is why the area of the master cylinder is kept smaller than the wheel cylinder or the piston, In case of disc brakes, it is the diameter of the piston, and in case of drum brakes, it is the diameter of the wheel cylinder. Brakes and braking action. How the brakes works and how it acts. It includes master cylinder and the drum and disc wheel brake mechanisms. The master cylinder is a reciprocating piston, as shown you here. The master cylinder is a reciprocating piston pump. It pressurizes the hydraulic system when the driver depresses the brake pedal. This converts the mechanical force into hydraulic force that applies the brakes at the wheels. Here you can see from the figure how the brakes works. This is a master cylinder. When a driver pushes the brake pedal, this is a brake pedal. When it depresses the brake pedal, it moves the piston from this position to this position in forward position, and the liquid in front of the position gets compressed and it flows through the tubes to the front wheel and to the rear wheels. Though the arrangement is different for different vehicles, but this is the general arrangement I have shown here. When the pedal is pressed, the liquid travels from master cylinder to the wheel cylinders. So, these are the front wheels and these are the pistons, and it pushes the pistons outward, and with the help of the calipers, the disc pads come into contact with the brake discs that applies brake. Similarly, it goes to the rear wheels and there are two pistons. It expands the pistons and moves the pistons outward and expands the brake shoes that applies the brake. So, braking begins at the brake pedal. So, braking starts from here, that forces brake fluid from master cylinder into the lines of wheel brakes. As hydraulic pressure increases, brakes are forced against the rotating drums. In this case, the resulting friction slows or stops the vehicle. Next is the dual braking system. What is dual braking system? In a dual braking system, the hydraulic system has a primary section and secondary section. The primary section is always closest to the firewall. However, the dual braking system is hydraulically separated. Most vehicles with rear wheel drive use the front rear split. Front rear split means the front wheels, as it was shown in the figure. This is the front rear split. These are the two pistons. This is the primary section, this is the secondary section. It is near to the firewall. Here it is called a firewall, and this is the primary, this is the secondary. It controls the front wheel, this controls the secondary. So, the primary section is always closest to the firewall. This is the primary section, it is the closest to the firewall, and the dual braking system is hydraulically separate. Most vehicles with rear wheel drive, so the vehicles which are equipped with the rear wheel drive system is separated as front and rear split. So, this system is for rear wheel drive. Many front wheel drive vehicles use the diagonal split. It means front wheel drive with diagonal split means the front right wheel and the rear left wheel is controlled by a single line, and the front left wheel and the rear right wheel is controlled by another line to make the brake effective in case of failures. So, one section, by doing so, the one section will continue to work and stop the vehicle if the other section leaks or fails. So, that means we are using the two systems, that is the primary and the secondary system. So, both are separated, and it rarely happens that the brakes will fail completely. It means that one section will remain working and it will not fail. It is almost impossible that all the wheels gets leaked at the same time. So, one wheel may leak or the other will leak. So, one section of the brakes will remain in working. Next is about the wheel cylinder. We have discussed the master cylinder, then wheel cylinder. It converts the hydraulic pressure from the master cylinder into the mechanical movement, because the piston's movement is to and fro. So, this to and fro motion will expand or contract the brake shoes. The wheel cylinder has two pistons with seal and spring in between. As the pressure increases, the piston overcomes the brake shoes return spring and push the shoes outwards in contact with the drum. You can see it here. This is a wheel cylinder, and this here the pressure comes into this cylinder, and these are the two pistons, both will expand outwardly like this. This piston will move in this direction, this will move in this direction, and it will open up the brake shoes. Here it is a spring which is called expander. The fluid pressure goes against the spring force. This spring force is responsible for the retraction of the wheel cylinders. So, these are the boots which are called seals here, and this is a bleeder valve. In case the air gets into the brake system, it has to be bleed out. So, this is a point from where air can be removed. So, you can see the wheel cylinder details. It is very simple in construction, but the working is marvelous. Then how the drum brake in operations. There are two types of drum brakes are leading, trailing or non-servo brake is used on the car wheels of many front wheel drive vehicles. The rear drive vehicles usually have dual servo rear brakes. In dual servo brakes, the action of one shoe reinforces the action of other shoe. In a leading trailing brake, the action of one shoe does not affect the other. See here, this figure shows the leading trailing drum brake and the dual servo drum brake. This is a leading trailing drum brake. Usually we are using this system, and in this system these are the brake shoes, wheel cylinder and here it is a retracting spring that brings back the wheel the brake shoes to its original position. And here this is a brake adjuster lever where the brake is adjusted automatically. In the older days, the due to the wear of the brake shoes, the brake has to be adjusted manually, but in nowadays we are using the technology in which the brakes are adjusted automatically. This is a adjuster in which there are ratchets. There are many kinds of adjustments. There is a one stop adjustment and there is a incremental mode of adjustment. We will discuss it later. So, usually we use the incremental mode of adjustment. So, the brake pedal does not go down, it is adjusted automatically, the brake shoes are adjusted. This is the adjustment which is in the brakes. And in this system it is a bit more complicated, because the brake of one shoe will enforces the brake on the other shoes, whereas in this system both are independent. This is leading shoe, this is the trailing shoe, and in this system the brakes are applied equally, the force is distributed on both the shoes equally. So, here is the drum brake self adjusters, as I have shown you in the picture, and most drum brakes self adjust to compensate for lining wear, because we are using the brakes very regularly. So, there is a lining wear of the shoes. So, that is why it has to be adjusted. This prevents the brake pedal from getting lower and lower during the normal use. Two types of self adjusters used in the leading trailing brakes are the one shot and the incremental. One shot means the brakes are adjusted only once, whereas in the incremental mode it is adjusted every time. There are very small adjustments which continue till the brake shoes are not completely worn out. The one shot makes a single adjustment when the clearance between the lining and drum reaches the preset cap. So, then no additional adjustments can be made. The shoes must be replaced and self adjusters reset. So, this is the difference between the one shot and the incremental adjusters. Some vehicles have self adjusters that works only when the brakes, self adjusters that works only when the brakes are applied while the vehicle is moving backward. There are many types of adjustments. So, here it is we have discussed, and the others are self adjusters works only when the brakes are applied while the vehicle is moving backward. If we move forward, the adjusters will not work. It will work only when the vehicle is reversed and the brake is applied, only then it will adjust the brake. In other vehicles, self adjustment occurs only when the parking brake is applied. The brakes can get out of adjustment if the vehicle is not moved in reverse or if the driver does not set the parking brakes. So, it means that the parking brake has to be applied regularly and the vehicle has to be reversed, only then the brakes could be adjusted, otherwise no adjustment and the pedal will go down and down. Okay. Then let us see the disc brakes. Disc brakes has a metal disc or a rotor instead of drum. It uses a pair of flat lined shoes or pads that are forced against the rotating disc to produce braking. The pads are held in a caliper that straddles the disc. The caliper has one or more pistons with a seal and dust boot. Dust boot is that avoids dust to enter into the brake system.